Welcome to The Explainer. Today we're diving into the fascinating science of turning everyday waste into clean energy and uncovering the perfect recipe to make it all happen.
So let's just jump right in with this question. What if you could take yesterday's French fry oil and turn it into tomorrow's fuel? It sounds a little like science fiction, doesn't it? But it's very, very real. We're going to be looking at a groundbreaking study that figured out how to create a more sustainable and efficient biofuel from something most of us just throw away: used cooking oil.
But, before we can really appreciate the solution, we've got to understand the problem. Why isn't every truck on the road already running on biodiesel made from old cooking oil?
Well, it turns out that making biodiesel at a huge scale has some major hurdles. For starters, the raw materials alone can make up something like 75% of the total cost. That's huge. The process also eats up a ton of energy. And the catalysts, those are the special ingredients that make the reaction happen, they often get lost after just one use. So it's not enough to just make biodiesel. The real challenge is figuring out how to do it in a way that's both economically smart and truly good for the environment.
So here's our roadmap for today. We're going to start with the scientists' clever solution, then we'll unpack the actual chemical recipe. After that, we'll see how they found that perfect sweet spot, explore the tricky balance between yield and efficiency, and finally, look at what all of this really means for a more sustainable future. All right, so how exactly did one scientist decide to tackle this massive challenge? Let's meet the mind behind this very cool solution. The lead author of the paper we're looking at today is Dr. Mahmoud Karimi. Now, he's an expert in what's called waste valorization, which is really just a fancy way of saying he's a pro at turning waste materials into valuable products. His work is all about using cutting-edge tools, like artificial intelligence, to create technologies that can help us switch over to renewable fuels much, much faster. And this study takes on that challenge head-on. See, the goal wasn't just to get the most biodiesel possible. No, the real breakthrough here was aiming to maximize that yield while also maximizing energy efficiency at the exact same time. It's a classic multi-objective puzzle, and that's what makes it so interesting.
All right, now for the really fun part. Let's get into the ingredients and the incredibly clever chemistry that makes this whole thing possible.
So the star of this whole recipe is a biocatalyst called lipase. It's a natural enzyme, and it's way greener and gentler than the harsh chemical catalysts that are often used in these big industrial processes. It basically gets the chemical reaction going without creating a bunch of nasty byproducts. But there's a big catch. High-quality lipase is expensive, really expensive, and when it's just floating around freely in the mixture, it's pretty much impossible to get it back to reuse it. For any kind of large-scale factory, that's a total deal-breaker. You just can't afford to throw away your most valuable ingredient after every single batch.
So the solution was to stop the lipase from floating free by, well, immobilizing it. The process is ingenious. They started with a tiny magnetic iron core. Then they coated that core in porous silica, you can think of it like a nano-sized sponge, to create a massive surface area. Finally, they attached the lipase enzymes all over that surface. The result? A high-tech catalyst that you can literally pull right out of the mixture with a magnet and use again and again. It's brilliant.
Okay, so now we have our reusable magnetic catalyst. That's great. But how in the world do you find the absolute perfect recipe to use it?
The researchers identified 4 key variables they needed to control, kind of like 4 knobs they could turn to perfectly tune the process. They had to get the ratio of methanol to oil just right, decide on the perfect amount of catalyst, add a very specific amount of water, which it turns out is essential for keeping the enzyme active, and then let the whole reaction run for the ideal length of time.
So to figure out the best combination of those 4 variables, they used 2 really powerful modeling tools. The first one is a more traditional statistical approach, but the second one, that was an artificial neural network, or ANN, an AI model that's actually inspired by the human brain. And as it turned out, the ANN was far, far superior. It was able to predict the outcomes of their experiments with incredible accuracy.
But this AI wasn't just looking for one perfect number. It was programmed to solve a really fundamental conflict between 2 competing goals. And here's the central challenge. Goal number 1 is to maximize FAME content. That's just the scientific term for the biodiesel yield. You want as much fuel as possible. Simple enough. But goal number 2 is to maximize Exergy efficiency. You can think of that as minimizing energy waste. You want the whole process to be as lean and green as it can be, and, well, it turns out the recipe for one isn't the recipe for the other.
So for instance, if you only cared about yield and you completely ignored efficiency, the model predicted you could hit an incredible 95.7% conversion rate, but doing that would take a full 25 hours.
Now, if you flipped that goal and only focused on maximum energy efficiency, well, you could reach 84.6%, but you'd have to cut the reaction time to just 5 hours, which would absolutely crush your total fuel output.
See the problem? You can't get peak yield and peak efficiency at the same time. The conditions are just totally different. This creates that classic optimization puzzle. Where do you find the perfect compromise? You know, the best of both worlds.
So where did the AI model finally land? Let's take a look at the final optimized recipe for what could be a real-world practical solution.
This is it. This is the sweet spot. Using their advanced AI model, the researchers found the optimal trade-off. By setting the variables to these very precise levels, they could achieve a fantastic biodiesel yield of 88.6% while still maintaining a really strong energy efficiency of over 80%. This isn't the absolute maximum for either goal, but it's the recipe that delivers the best overall performance.
And as the authors themselves put it, the future of green energy isn't just about output. True sustainability means you have to optimize for both productivity and efficiency. You've got to consider the whole picture, from the ingredients you use all the way to the energy you might be wasting.
And that leaves us with a really fascinating question. This study, it's more than just a recipe for better biodiesel. It's a blueprint for solving all kinds of complex problems. It shows how we can use these powerful AI tools to find the perfect balance in almost any system that has competing goals. It really makes you wonder, what else could we perfect?